Hello, and today's purpose of the day is I can simplify mixed expressions. Please take some time to find the following two problems. Number 1, 5 plus 3/7, and number 2, 18/5 minus 1. Please show all of your work. Number 1, 5 plus 3/7. Well, this one is fairly simple. 5 plus 3/7 is just 5 and 3/7. But let's say we wanted this as a improper fraction. What would we do in order to get there? Well, you're thinking we could take 7 times 5, get 35, add 3, and get 38/7. That one is pretty simple. I'm just going to recap and go through the work of what this would look like if it wasn't so easy to do a problem like this. We would want to get a common denominator, so our first number 5 would be like 5 over 1 if we turn that into fraction with a denominator plus 3/7. In order to add fractions, we need a common denominator. So I would multiply the first fraction by 7 over 7 and get 35/7 plus 3/7. Add together the numerators and get 38/7, which as a mixed number is 5 and 3/7. Let's take a look at the second one, which might not be as easy as the first. So 18/5 minus 1 over 1, if we turn that into a fraction with a denominator. So to get a common denominator between 5 and 1, that would be 5. So I would multiply the second fraction by 5 over 5. So I get 18/5 minus 5 over 5, which then would give me 18 minus 5 all over 5, which would be 13 over 5, which if I change that to a mixed number would be 2 and 3/5. So this will be very helpful for us today when we are simplifying mixed expressions. A new vocabulary word for 11.7 is a mixed expression, and a mixed expression is an expression containing the sum or difference of a monomial and a rational expression. So again, monomial means one term, and rational expression is a fraction. And that fraction could have numbers, could have variables, could have the product numbers and variables, it could have the sum or difference of numbers and variables. So let's provide an example. An example could be 6x plus 3 over y, right? We have one term, which would be the 6x, plus a rational expression with a fraction, which would be 3 over y. Another example we could see could be like x minus 2 over 3, so that would be the rational expression minus 5. That would be my monomial. Can you think of an example? Great job. One last example that I could come up with is we could flip-flop and put the monomial first, minus x over 5, and that would be my rational expression. Here are just a few examples of what a mixed expression looks like. Let's go through a few examples of simplifying mixed expressions. What would you do on number 1? 2 plus 5 over x. Nice work. We need to rewrite 2 over 1 and say 2 over 1 plus 5 over x. And the only way we can add these rational expressions, or this monomial plus this rational expression, is if I get a common denominator. So a common denominator of 1 and x would be x. So I would multiply both sides by x. So I would say times x over x, and I would get 2x over x plus 5 over x, which would equal, well, 2x plus 5, I can't put those terms together because those aren't like terms, so I would just get 2x plus 5 all over x. And I can't simplify because there's no term that I could take out of the 2x, the 5, and the x in the denominator. So that would be my final answer. Let's take a look at number 2. 3 plus 7 over x minus 2. Again, great job to start. We want to put 3 over 1. And so I have 3 over 1 plus 7 over x minus 2. So a common denominator of 1 and x minus 2 is x minus 2. So I'm going to multiply this first fraction of being multiplied by x minus 2 over x minus 2. So I get 3 times x, which would be 3x. 3 times negative 2 would be negative 6. And I could say plus 7 all over a common denominator now of x minus 2. And here I can put together this negative 6 plus 7 to give me a 1. And so this would be 3x plus 1 all over x minus 2. And again, there's nothing I could factor out or cancel out because there's no terms that can, so that would be my final answer. Number 3, 6x over 4x minus 8 plus 5x. So I'm going to start this by putting the 5x over 1, and now I need a common denominator of 4x minus 8 and 1, which would be 4x minus 8, so I'm going to multiply both the numerator and the denominator by 4x minus 8. So when I do that, I get 6x, that didn't change right there, plus 5x times 4x is 20x squared. 5x times negative 8 is minus 40x, all over 4x minus 8. This one's got a little bit more going on than the other examples, but let's look at simplifying. So here I will look at the 6x minus 40x, which is negative 34x, so the 20x squared didn't change, minus 34x, all over 4x minus 8. And let's look at factoring and simplifying here. So out of the 20x squared and the negative 34x, I'm going to factor out a 2x. So that's the GCF of the two. And then I get 10x minus 17. All over, now with the 4x minus 8, what can I factor out? I can factor out a 4, and then get x minus 2. And now let's look at simplifying. So if I cancel out here, the 2 becomes a 1, the 4 becomes a 2, and that actually is everything I can cancel out. So my final answer would be x times 10x minus 17 all over 2 times x minus 2, and that would be my final answer. Okay, in example 4. I didn't have enough room on the last slide, so I just added a new page here. But take some time right now to figure out what the simplified answer would be for this mixed expression, x plus 2 over x plus 3. All right, let's go through the step-by-step answer. So I really have x over 1, so I need a common denominator of 1 and x plus 3, which would be x plus 3. So I'm going to multiply here, and I get x squared plus 3x plus 2 all over x plus 3. And let's look at factoring this numerator and figure out factors of 2 that when added together that give me 3 would be 2 and 1. So when I factor this, I end up getting x plus 2 times x plus 1 all over x plus 3. So there actually isn't anything that I can cancel out here, and this would be my simplest form. Thanks for listening. Have a great day. Bye-bye.